chord. Okay. All right, leading coefficient, nobody asked me about that. You had it all correct. So if I look at standard form, right, it's the leading coefficient if it's in standard form, so 4. All right, we need to find the vertex so we can get the axes of symmetry. Ladies. Okay, look, how do you find the vertex? There's 2 ways of solving it, so I'm going to cover this up, okay? All right. And it's whatever you prefer. Some of you, as walking around, you guys are working off this factored form because you have the intercepts being 1/2 and -1/2, and so you want to work off the intercepts. Okay, so if I take a table, here's -1/2, right? Here's -1, here's 0, here's 1/2, here's +1. Okay. If this is where your 2 x-intercepts are located, your vertex is always at the midpoint. It's at the halfway number. That's your x value. So if they're halfway, well, together that's 1 unit. What's half of 1 unit? A half. So you either go a half from the right or a half from the left. Either way, 0 is your halfway number, right? It's pretty intuitive. You're like at the positive and the negative, so 0 is the halfway mark. Okay, so that means you know for your vertex, the 0 is your x value. You now need to find your y value. Substitution. Okay, so can I substitute? All right, so if I substitute, you could take the 0 into factored or standard. It's up to you. But if I take it into standard, 4, 0 squared minus 1, anything times 0, 0. And so I end up with a -1. That's my vertex. Okay. I'll eventually move it and do the axis of symmetry and max min, but so far, hold on, let me redo it now. What if you don't want to work off the intercepts? How do you find the vertex? Keep going or wait?
You're good.
I'm good. Okay, so remember, this is in standard form. You don't have a bx term, but it really is there. Plus 0x minus 1, right? A, B, C. Okay, to find the vertex, minus b over 2a. Well, if my b value is 0, 2, my a value is 4, it doesn't matter. Once you have 0 as your numerator, isn't it just 0? It's irrelevant what the denominator is. And so this just collapses to 0, right? And so there's my 0. And if you substitute it, you're going to get the exact same -1. So the only thing you need to remember is if you're going to use the vertex, you have to know that formula from standard form if you don't have your intercepts. So this is an or. This or this. You just, whatever you prefer. Move it to the little boxes. Yeah, okay. So look, I'm going to refer back to this. So if we, wait, let's see where the boxes are. Hold on. Okay, so where's the vertex? Right here. We got 0, -1, right? Okay, is the parabola up or down?
Up.
Up because this number is a positive 4, right? So it's up because your A value is positive, right? Good job. Okay, what's my axis of symmetry? It is always this number, the x value of the vertex. Was it 0? I don't want to mess up. Right? Oh, it's crooked. I wasn't even looking up. Okay, max or min. If it's a up parabola, it opens up. Where's your vertex? At the max or the min? Remember, your little vertex would be right there.
Min.
Min, very good. So it's min. If it was concave down, right, if it opened downward, it would be at max. If it's up, it's always a min, because it's the lowest point. Okay, your domain is on parabolas are all reals. You can write it, or you can put that double spine R. Your range is always based off the y value of your vertex. So because it is concave up, we're going to be at -1, and it's going to be approaching positive infinity. That's a bracket, that's a parenthesis. And then we'll get a graph in a second. I forgot, it's still recording. I wonder what the amount of minutes is the limit. I know for YouTube, if you're not recording live, 15 minutes is kind of the max. But I don't think I've been talking for 15 minutes.
It's one.
From my phone, it's only 15. I'm only allowed 15.
Oh yeah, on the phone, but like on the computer, it's
Oh,
more.
it's more? Oh, okay, good. Oh, I can keep talking. All right, let's put the little graph. Yeah. 4, 6, 2, 16. But you're good. So just put a little negative infinity right here. And that's gorgeous. And is it max or min? Perfect. Gorgeous. Love it. Okay, if I plot, what did I say? 1/2, -1/2? Wait, that's a 1, so that's a -1. 0, -1. Oh, you guys, it's like a little baby. Little problem. All right, there's your, and then my axis of symmetry. Wow, the axis of symmetry is here. You just can't. There's my axis of symmetry. Okay, let me stop this. Wait, did I fill? Oh, guys, end behavior. Okay, your two end behaviors are when x is approaching positive and negative infinity, what are the y values? How are they behaving? Okay, as the parabola, as I substitute more negative values into this equation, either one, the parabola is still shooting up to positive infinity. And they're always the same for parabolas. So as more positive x values get substituted into either of these two equations, you're still going to end up with a larger positive y value. And so if it's concave up, if the x's are approaching positive or negative infinity, the y values are moving to positive infinity. If it was concave downward, or if it opened downward, it would be at negative infinity because the parabola is going downward. Hey, look at this. Oh, hey, this one's like, oh, the last one was like kind of the easiest, huh? Oh, awesome. Sergio, I will get that in. Oh, let me hit stop. Whoopsie. But then it's gonna stop for you guys. Hold on, let's see. I think it might. Let's see if I can. Hold on a second.